Hello dear, welcome. Let's discuss the next question together. Here it is our question. The statement is, in figure ABC is a triangle in which angle ABC is greater than 90 degrees and AD perpendicular to CB produced. You can see in figure in ABC triangle angle ABC is greater than 90 degrees. You can see it looks like an obtuse angle, right? So this is given, and AD perpendicular to CB produced. Here AD perpendicular to CB produced. So when CB produced, then here AD is perpendicular to this line, right? This is given information. By using this, we need to prove that AC square equals to AB square plus BC square plus 2 times of BC into BD. AC square is equals to AB square plus BC square plus 2 times of BC into BD. This is what we need to prove, right? So hypotenuse square equals to something. So anyhow, this is look like expansion of an algebraic expression a plus b whole square, right? So anyhow, we will use here, right? So let's prove this. Okay. Given ABC is a triangle in which angle ABC greater than 90 degrees and AD perpendicular to CB produced. Whatever given statement as it is we have taken. To prove AC square equals to AB square plus BC square plus 2 times of BC into BD. This is what we need to prove. So for that, so this is the proof. Since triangle ADB is a triangle right angled at D. Here ADB is what? It's a right angle triangle, right? So here ADB is a right angle triangle, right angled at D. Therefore, by Pythagoras theorem, what we can say? This square equals to this square plus this square. That is AB square equals to AD square plus DB square by using Pythagoras rule. That is side square plus side square equals to hypotenuse square. In other terms, we can say hypotenuse square equals to side square plus side square. So let us take this is equation number 1, right? Now further, in triangle ADC, again this is the right angle triangle, right angle at D, right? Again we can apply Pythagoras theorem. So hypotenuse is AC this time. So AC square equals to AD square plus DC square. AC square equals to AD square plus DC square. This is hypotenuse, this is side, this is another side. So hypotenuse square equals to side square plus side square, right? Now we know DC is equals to, what is DC? DB plus BC, right? This whole length is equals to this plus this, right? So we can replace DC with DB plus BC. Anyhow, square is there, so whole square. So AC square equals to AD square plus DB plus BC whole square. Clear? So this is look like A plus B whole square. So we will expand by using algebraic identity A plus B whole square, A square plus B square plus 2AB, right? So by expanding this, AC square is equals to AD square plus DB square plus BC square plus 2 times of DB into BC, right? Now further, AC square equals to, here AD square plus DB square together we have taken as a term, plus BC square plus 2 times of DB into BC. AD square plus DB square, what we have got in earlier? So in 1 we have proved that. What is that? AD square plus DB square is equals to AB square. Got it? So this we will use here. So we can replace AD square plus DB square as AB square. So AC square equals to AB square plus BC square plus 2 times of DB into BC. This is equation from 1. Now this is what we need to prove. So hence it is proved. Clear? Simple, right? Shall we discuss once again briefly? So very simple. In the figure, ABC is a triangle in which angle ABC greater than 90 degrees and AD perpendicular to CB produced, and we need to prove that AC square is equals to AB square plus BC square plus 2 times of BC into BD. BC into BD. This is what we need to prove. So this is given statement as it is we have taken from the question. ABC is a triangle in which angle ABC is greater than 90 degrees. So obtuse angle, you can say this is obtuse angle triangle, right? So here AD is perpendicular to CB produced. So then here you can see one right angle triangle ADC, okay, and another right angle triangle ADB. So here what are all we have done to prove this is, first we have considered ADB right angle triangle. So by applying Pythagoras rule, so then AB square equals to AD square plus DB square, that is hypotenuse square equals to side square plus side square. This is what? Equation 1. So here we have got AB square value. This further we have used somewhere. Again we have considered ADC right angle triangle. So again we can apply Pythagoras rule. This time hypotenuse is AC, so AC square equals to AD square plus CD square. AD square plus CD square or DC square. Again DC is nothing but this whole length is, you can see, you can rewrite as DB plus BC, right? DB plus BC whole square. And expanding this we have got DB square plus BC square plus 2 times of DB into BC, or else you can say BC into BD also, okay, it doesn't matter. Then together these two terms AD square plus DB square, from equation 1 we have got that is AB square, okay. So AC square equals to, we have replaced as AB square plus BC square plus 2 times DB into BC or BC into BD. This is what we need to prove, so hence it is proved. Clear? This is it.